Hello everyone. Today we're going to talk about a very common data structure called array. So many of you are already familiar with array. So array is actually basically a linear list of data. And as we know, any data structure is actually used to store and organize data. And in case of array, if we draw an outline, this looks like this, right? And suppose this array is of size 4 and the data inside it is different integers. So 1, 30. And as you can see, in most cases or in most languages, array just stores homogeneous type of data. That means all of them are of the same type. It might be an array of characters, or in this case, the example that I am showing you here is an array of integers. All of them are integers. Another thing is the data is stored, how the data is stored. So the data is stored in continuous order. So we are not going into implementation details, but even in computer's memory, this data is actually put in continuous blocks. And another thing is array has usually fixed size. Okay. Okay, and since it has fixed size, each block has an index. Each block has an index. So usually the index starts from 0. So these are the index. And let's put the values again here. And because every block or every data in this list or in this array has an index, one of the advantages of arrays are random access. So what we mean by random access is just mentioning the index, we can directly access that data. So let's say if I say index 3, get the data from index 3, I can just directly jump and grab the data from there. Okay. So how do I declare an array? In most of the cases, this is the notion how we declare an array. First, you put a data type, because array is a list of homogeneous data, but it might be of different data types. In our example, we are showing integer data, and then you put these braces or brackets, and you give it the name, the array name. So this is the convention of how you declare an array. So let's see some of the examples, and I will be showing you examples from Java. So example, okay, let me show you. Search this. Let me run on one of the programs. So you see, okay, so here is an array example that you see. So integer, and these braces say this is an array of integers, and name of the variable is age. And this is also not only declaring an array, also initializing it. So new int, and then this one says I'm creating an array of size 5. Okay, so once you do that, then what you can do is you can just mention the index and put the value there. And eventually this array will be looking like this. Okay. And then you can access the elements of the array by its name and index. So let's run this piece of code. So here is another way to initialize the array. In Java, you can just, instead of just saying like new int 5, instead of like doing this and then assigning, so this is one way, just we showed you, right? 12, etc., etc. Instead of doing this, I can just do this. And what's going to happen is an array of size 5 will be created where the values would be filled in the array sequentially. So this is going to be in index 0, this is going to be in index 1. Okay, and then this is the random access. So I can just access any value using the index. Okay, so you see age 0 is now 12. Okay, so we can see that because of the index, we can just do a random access of the variables, right? 4, 10, 1, 30. So this is also say this is an age array. The name of the array is age. We can say age 3, and directly it will just get me 30. Okay, if I say age 3, it will go inside the array and grab the value and return 30. That means accessing the array is order of, it can be in order of 1. Okay. Now deleting from the array, say I want to delete from the array. Say I want to delete age. So this is the age array. Name of the array is age 0. So in that case, what's going to happen is if you delete this, you cannot just keep it empty. So you have to shift everything to the right. So it will be 10, 1, 30. So deletion can be costly. It might be order of n. Now insertion, in case of insertion, insertion actually depends. So in the example here, let's see, in the example here, when we actually initialize the array, we mentioned 5 values. So that means every element was added to the end of the array. So that means it was like this. If I make the same array for that. So the first element was put 12, 4, 5, 2, 5. 12, 4, 5, 2, 5. So each element was being added to at the end of the array. In that case, each insertion was probably taking order of 1. That is fine. But if you say like, if you're not inserting to the end of the array, instead say you are inserting somewhere, say insert into the beginning. Okay, age 0 equals to 6, something like this. In that case, you may need to shift everything to the right. And then put 6 here. So that might be order of n. So if you insert in a particular position. Okay. So there goes more or less the discussion on an array. As you can see, to recap, array is a linear data structure, which you see here. It actually is a list of homogeneous data type. It has static size, and then the values are put in continuous order. So even if you delete something, you can't keep it empty. So everything has to shift, and then whatever data is here has to be in continuous order. And the last thing is the access of array is very easy because each element has an index. So you can just directly jump there and access the value. So that's it, our discussion about array, and we talked about just the abstract data structure. So we didn't talk about the implementation details or how different programming languages are doing it. Instead, we just talked about the basic features and characteristics of array. We'll come back again with another type of data structure. So in the next one, we'll be talking about another linear data structure, which is also a list that is called linked list. And after the discussion of linked list, we will try to see what is the difference, basic difference between array and linked list.